Okay, let's jump right into this explainer. We are tackling a massive, highly consequential scientific mystery today. We're going to figure out exactly why Europe is absolutely baking right now, heating up at a vastly accelerated rate compared to the rest of the world. And honestly, by the time we wrap up here, you're going to see just how deeply, crazily connected our global climate system really is.
Look, we all know the globe is warming. That's a given. But researchers have spotted this staggering regional anomaly in the data, and it completely demands that we ask, why is Europe's heat breaking all the rules? Heat extremes are up globally, sure, but ever since that incredibly deadly summer of 2003, right through to the scorching consecutive summers of 2018, 19, and 20, Europe has just been a glaring outlier.
And the stakes here, they're incredibly high. When you look at data from the past 42 years, it reveals that Europe is seeing an upward trend in heat waves at a rate 3 to 4 times faster than the rest of the northern mid-latitudes. 3 to 4 times. To put that into perspective, while other mid-latitude regions are getting an extra 0.21 heat wave days per decade, Europe is getting an extra 0.61 days per decade. That is a massive discrepancy. Europe isn't just warming up with the rest of the class, it is literally sprinting ahead of the pack.
Just look at that intense, dark red concentration parked right over Europe. That perfectly maps out the accelerated trend we're talking about, showing both the frequency of heat wave days on top and the cumulative intensity on the bottom. While parts of central North America are actually seeing a slight cooling trend, a sort of warming hole, Europe is just glowing dark red. It's the undisputed hotspot for intense compounding heat.
Section 1. The usual suspects versus the real culprit.
So, general greenhouse gas warming, thermodynamic changes, those are the usual suspects, but they apply everywhere. They don't actually explain this highly concentrated, localized hotspot specifically over Europe. To find the real culprit, we've got to look way up, deep into the atmospheric dynamics of the upper troposphere. The answer is something called a double jet stream. It's an actual structural change in our atmospheric circulation over Eurasia. Normally, our jet stream is a single, powerful band of wind. But the data shows a huge upward trend in both how often and how long this jet stream essentially splits into 2 distinct branches.
To really grasp why this matters, think of a normal single jet stream as a fast-flowing river of air. It acts like an atmospheric conveyor belt, just constantly pushing weather systems along from west to east. But a double jet, that's more like a divided highway. You've got a northern path and a southern path, and right in a median between them, the air just stops moving. It allows these stagnant, high-pressure weather systems to stall out, just sit there, and absolutely bake the land underneath.
And you can see that physical split brilliantly here. Notice that zone of weak, negative wind anomalies right in the middle latitudinal belt, between 45 and 65 degrees north. That pale, calm center, it sits exactly over regions like the UK, France, Germany, and the Baltics.
So here's the crucial takeaway. Those weak winds essentially cause a massive traffic jam in the sky. Meteorologists call them blocking anticyclones. Because you don't have the strong winds of a single jet stream to push weather fronts through, a stagnant heat dome forms. And that dome locks intense, compounding temperatures in place over Europe, not just for hours, but for days or even weeks at a time.
Section 2. The evidence in history.
Now, let's take all this atmospheric theory and see how it translates into devastating human reality on the ground. Science is always most powerful when we can map models to events we've actually lived through, right? The researchers mapped this double jet phenomenon to specific severe recent summers. They looked at 1994, 2006, 2018, and of course the absolutely tragic 2003 heat wave. 2003 saw one of the strongest European heat waves of the observational era, resulting in roughly 70,000 excess deaths. And when you look at the skies during those exact periods, the data reveals something incredible.
Check out the data from 2003 right here in the second row. You can see exactly how the long-lasting double jet wind anomaly perfectly aligns with the massive spike in the heat wave's cumulative intensity. The double jet established itself in early July, and boom, the heat wave immediately developed over central France. Then it spread right across Spain, Italy, the UK, and Germany. The stagnation trapped the extreme heat precisely where the winds were the weakest.
And look, this isn't just a random coincidence for a couple of bad summers. When scientists run the linear regression models, they find that these double jet occurrences explain up to 35% of the day-to-day temperature variability for Western European heat waves. 35%! That is a massive chunk of the climate puzzle, totally solved by looking at just one specific atmospheric wind pattern.
But honestly, here is where the findings get truly staggering. Remember that accelerated trend we talked about at the beginning, the warming that happens above and beyond the global average? We call that the residual trend. Well, the upward trend and the persistence of these double jets explains nearly 100% of that accelerated residual heat wave trend over Western Europe. It accounts for almost all of the excess warming the region is dealing with.
This comparison just confirms it beautifully. The observed excess heat trend on the left matches incredibly closely with the estimated trend on the right, which relies solely on the double jet data. The models capture the vast majority of this excess European heat, especially over regions like France, the Iberian Peninsula, and the UK. It's a near-perfect match.
Section 3. The root cause, the Arctic connection.
Okay, so like any good detective story, finding the weapon just isn't enough. We need the motive. We know the double jets are causing the heat waves, but why are they becoming more frequent? Why are they persisting for longer and longer periods of time? To answer that, we actually have to look away from the baking streets of Europe and turn our attention way, way up to the far north. The changes happening at the absolute top of our planet are sending massive ripple effects straight down into the mid-latitudes. The study points the finger straight at a phenomenon known as Arctic amplification. Here is the causal chain. During the summer, Arctic land masses, places like Siberia and northern Canada, are warming much faster than the cooler Arctic Ocean. This unequal warming cranks up the thermal contrast just north of the Arctic Circle. That intense temperature difference acts like an engine. It strengthens the northern polar front jet, which then essentially locks these double jet regimes into place over Eurasia.
It's a fascinating and frankly kind of sobering realization, because snow cover is melting so rapidly in places like Siberia early in the summer, the land heats up drastically. And that faraway land heating alters atmospheric winds across the entire hemisphere. It literally directly contributes to baking cities like Paris and London weeks later. It just goes to show, our planet's climate is one tightly woven fabric. You pull a thread in Siberia, and things heat up in France.
Which leaves us with a pretty critical thought to ponder as we wrap up. The researchers note that many current climate models actually underestimate the observed warming trend over Western Europe, likely because they just aren't fully capturing these complex jet stream dynamics. So, if the models are underestimating these double jets right now, and the Arctic just keeps warming, what exactly does the future hold for Europe? Are these deadly heat waves the new normal, or are we just at the very beginning of a much steeper, hotter curve? Keep that in mind the next time you check the summer forecast. Thanks for joining me on this explainer, and I will catch you next time.